Hiya, Mr. Green here. I'm going to be taking you through the first lesson of atomic structure in physics, which is atoms and radiation. I'm going to start with the basics of atoms to know the structure of atoms and isotopes. Quick retrieval practice here, some knowledge that you may know from year 9 or previous years. So pause the video whilst you attempt those 5 questions. Okay, then we'll kick off with question 1. The centre of an atom is referred to as the nucleus. And what do we find at the centre of the atom? Within the nucleus, we'll find protons and neutrons. Question 3. What do you find in orbits around the centre of an atom? Well, in orbits whizzing around the outside are electrons. When we look at the periodic table and descriptions of atoms, what does the mass number tell you? That will tell you the number of protons and neutrons in a nucleus. And what does the proton number tell you? It only tells you the number of protons. These have become more important during the lesson. We'll go through these in detail. So our learning outcomes for today is to state the structure of an atom, to describe what's meant by an isotope, and to explain what is meant by ionization. All concepts that will follow us all the way through radiation and will be useful to know at the start. So first off, pause the video whilst you draw what you think an atom looks like. And your challenge little at the end there is, how big do you think an atom is? So pause the video whilst you attempt that first task. Okay, let's have a look at what an atom actually looks like. So, an atom is a nucleus in the centre containing protons and neutrons, a big space in between that, and then orbiting around the outside are electrons in different energy levels or shells. The number of protons in the atom will tell you what the atom is. So in this case, we've got 6 protons. That means that it's carbon. Atoms are really small. The radius is around 1 times 10 to the minus 10 meters. That's 1 with 10 zeros before it, so ridiculously small. Basic structure is a positively charged nucleus with protons and neutrons, and it's surrounded by negatively charged electrons. Now the atom itself is quite small, but the nucleus itself is 1/10,000th of the radius of the atom. So it's tiny, it's a real small speck in the middle of an atom. And most of that mass is concentrated in there. So the mass is mainly empty space with a positive nucleus and electrons round the outside. Now each particle's got its own charge and its own mass, each subatomic particle present in an atom. We have protons, neutrons and electrons. Protons have got a mass of 1.672 times 10 to the minus 27 kilograms. Neutrons 1.675 times 10 to the minus 27. And electrons 9.10 times 10 to the minus 31. I've written out the mass there in actual kilograms so you can see exactly how small it is. It is a ridiculously small mass. And if we started working with that in science, we'd find it very complicated to keep up what we were talking about and compare. So what we do is we look at the relative mass. How much do they weigh compared to each other? We state a proton has a mass of 1. Neutrons weigh exactly the same as protons, so we say they also have a mass of 1. Electrons are much smaller, closer to 0. They weigh a proton divided by 2,000. You would need to have 2,000 electrons to equal the same mass as 1 proton. Relative charge of each. Protons are positively charged and have a charge of +1. Neutrons are neutral and have no overall charge. And electrons have a charge of -1. Again, pause the video whilst you take that table down. It is going to be important as we move later on in the lesson. Okay, so when we look at a periodic table or we see any representation of atoms, we see this representation. We've got Cl with 35 and 17 there. So what do those numbers mean? Well, the top number tells us the mass number. That tells us everything we need to know about the nucleus. It tells us how many protons and how many neutrons are present in the nucleus. The bottom number in this case, which is 17, would be the atomic or the proton number. That tells us just the number of protons in the atom. Symbol in the middle, Cl, tells us what atom it is. So the top number, or the mass number 35, is the protons and neutrons. Bottom number is the atomic number. Now they may flip over when you see different periodic tables. The atomic number might be on the top, or the mass number might be on the top. What you need to remember is the lowest number out of the two, that's always the atomic number. That is always the number of protons. Now, how do we work out the electrons? Well, atoms in the periodic table have no overall charge. We saw from our table a minute ago, protons are positively charged, electrons are negatively charged, and neutrons have no overall charge. Now, negative charges cancel out positive charges. So if an atom's got 15 protons, what does it also need to have no overall charge? The 15 protons give us a charge of 15 plus, 15 positives. We know negatives cancel out positives, so it would need 15 negative charges. As electrons are negatively charged, the atom would need 15 electrons to balance out those positive charges. That's your basic rule. If an atom has no overall charge, the number of protons is the same as the number of electrons. Pause the video while you write that rule down. Okay. So here's an example. A radium atom's got 88 protons and 226 neutrons. How many electrons would it have? Well, we know from previously that radium atom is neutral. It says it's got no overall charge. So 88 protons are 88 positives. In order to cancel those out, we'd need 88 negatives, so it would have 88 electrons. Number of neutrons. How do we work this out? Well, to calculate the number of protons, we need to subtract the proton, or the atomic number, from the mass number. Another example here is fluorine. Fluorine, as we can see, has got an atomic number of 9, always the smallest number, and a mass number of 19. So it's got 19 protons and neutrons and 9 protons. So how do we calculate how many neutrons? In this case, the mass number is 19, the proton number is 9. To work out the number of neutrons, we take the atomic number away from the mass number. In this case, that's 19, take away 9, giving us 10 neutrons overall. Again, we can try it here. Uranium's got 92 electrons, a mass of 238. How many neutrons does it have? Again, we know it's neutral, so it must have 92 protons. Its mass is 238. 92 of those 238 are protons, so anything that remains must be a neutron. So we do 238, take away 92, giving us 146 neutrons. For the next section, you'll need the periodic table. I've placed one on the board there for you. There's a link at the top where you can go there to download a periodic table for yourself. But periodic tables are really useful to us. So, for this table, if you could fill in all the blanks for me, copy the table down and fill in the blanks. I've done the first one for you, looking at the periodic table. Hydrogen with a mass number of 1, atomic number of 1, no neutrons, and 1 electron. Pause the video whilst you copy that down, and you use your periodic table to fill in all the blanks. Okay, I'll put the answers up now for you. You should have got this. So using your periodic table, you should be able to fill those in all the time. Please pause the video whilst you check your answer there and ensure that you've got everything correct. Okay, moving on. Isotopes. Isotopes become very important in radioactivity. We can see 3 diagrams there. All of those are hydrogen. The positive represents a proton, the N a neutron. So, we've got 3 atoms of hydrogen there. How are they different from each other? Pause the video whilst you answer that question. Okay, the difference between them is each atom contains different numbers of neutrons. Every atom there has 1 proton, which means they're all hydrogen. The number of protons determines the element. Anything with 1 proton is hydrogen. But we can have different numbers of neutrons. Atoms that contain the same number of protons but different number of neutrons are called isotopes. So for the following atoms, calculate the number of neutrons within each isotope. Pause the video whilst you do that and unpause once you want the answers. Okay, number 1 then. So the first beryllium atom has 5 neutrons, the second has 8, and the third has none. We're taking the small number, the atomic number, away from the mass number. Second one, titanium, the first one has 26, second one has 30, and the last one has 20 neutrons. Again, they're all titanium because they have 22 protons. The number of neutrons changes, making them isotopes. Basically, radioactivity then, what is it? Well, a radioactive substance releases nuclear radiation, which is a type of ionizing radiation emitted from an unstable nucleus. So what we need to know is what's ionization and what's meant by unstable. Okay, ionization. An ion is described as a particle with a positive or a negative charge. Ions can be created by the atom gaining or losing electrons. This unbalances the charges in the atom. To be neutral, it needs the same number of protons as electrons. If it gains or loses electrons, then that will unbalance the charge. Ionization is where a neutral atom is physically changed into a charged atom because it loses one or more electrons. Let's have a look at the diagram here. We have an atom there with the electrons on the outer shell. An energy source has come in and hit that electron and knocked it off. Radioactive materials emit particles that can do exactly this. They do this by colliding with the atom with enough energy to knock an electron out of that electron shell. Now, if an atom loses an electron, it then has more protons than electrons, and that makes it overall positively charged. And any atom with a charge is referred to as an ion. What about these stable and unstable atoms then? Well, most atoms are stable. That means the forces among the particles present in the nucleus are balanced between the protons and the neutrons, making sure they're all together. But some atoms are unstable. Forces among those particles are unbalanced. It doesn't sit well with it. The number of protons and neutrons is not in the best sort of combination to make sure they all stay together. This means the nucleus needs to lose some energy in order to become balanced and become stable. Some isotopes that we've just been looking at will give rise to unstable nuclei, and those nuclei will emit radioactive particles to lose some of that energy and then become stable. Okay, so we've got a quick progress check for today's lesson. Could we answer these 6 questions? Pause the video whilst you do so, and unpause it and I'll go through the answers. Okay, question 1. What's present in an atom? We have protons, neutrons and electrons. Question 2. How can we calculate the number of neutrons in an atom? We take the atomic number away from the mass number. That's always the smallest number away from the biggest. How can we calculate the number of electrons in an uncharged atom? It's that uncharged that tells us what we need to know. If it's uncharged, the positives balance out the negatives, so the number of protons would be equal to the number of electrons. What's meant by an unstable nucleus? Well, an unstable nucleus is where the forces between the particles are unbalanced. It's got too much energy. It needs to release some of that energy in order to become stable. What's meant by an isotope? Well, an isotope are atoms that contain the same number of protons but different numbers of neutrons. Now remember, isotopes can give rise to unstable nuclei, and that's what will decay in order to emit radioactive particles. Question 6. What's different between the following atoms of carbon? Well, you should notice they are all isotopes. They all have 6 protons but different numbers of neutrons. So they've got different numbers of neutrons, making them isotopes. First one's got 6 neutrons, second one's got 7, third one's got 8. Okay, that's the end of our introduction to atomic structure. The next lesson we'll look at how we know the atom's the shape it is, and we'll look at radioactive particles. If you need to review any of this, please just watch the video again and pause it at the right points. Hope it's been useful. See you soon. Goodbye.